drink your coffee. Let's get started. Welcome. Behind me, I have my team dared me to put in our mascot, which is a stormtrooper with motorcycle gear holding a hockey stick. So that should give you some insight on how we operate. All right. All right, let me share my screen. Yeah, let me close my door real quick. Okay, so I was asked to do a topic on Angular, and I run a few Angular boot camps, and I wanted to. I didn't want to just run through the how do you start up Angular and things like that. Most of that stuff you can find online, and it's pretty straightforward. So I wanted to do something a little provocative, and so I wanted to talk about why we even bother with Angular. Okay. So my name is Ian Hamilton. I'm the operating partner at Intention Design Studio. And I'm also the principal of the sister company, Black Lotus Digital, which does the consulting branch of that company. Okay. You can visit our websites at the corresponding domains, or you can reach out to me directly via email. Okay. Okay, so what do we do? What does Black Lotus Digital do? Well, our main specialization is speed to market, high functional output teams, strike force on challenge projects, and tightly funded innovations. What does that mean? That means that ultimately what we do is we come in and we implement innovations that leverage the business for business edge, right? And so one of our focuses is getting as much functionality out the door as possible to leverage the business so that they can make money. Now, that doesn't necessarily mean that we cut corners. In fact, it doesn't mean we cut corners. One of the things that we see often is things of like non-tests and non-CI/CD builds and things of that nature. None of that gets shortcutted, even though we were able to to output high volume. So how do we do it? Well, all of these are accomplished by technology choices. Okay, so high output can literally be accomplished by choosing the right technologies. Okay, and so what I'm doing is I'm foreshadowing a little bit into the discussion we're going to have about Angular, and not just Angular, but a bunch of front end stuff. Okay, so let's talk about that. So in the past 5 or 6 years, we've been full stack development, but we've focused on mainly front end web technologies. And so in the past, like 5 or 6 years, we've implemented several different kinds of front end technologies, including Vue.js, which is believe it or not, is the world's most popular front end technology worldwide. React, everybody is familiar with React. Well, should be familiar with it. Lightning, which is, if you've never heard of Lightning, Lightning is the progressive web app or the single page app framework for Salesforce. Google Polymer. Electron, if you've never heard of Electron is a Chrome-based desktop system. So if you've ever coded in VS Code, let's say, you are actually coded in Chrome. Okay, and Angular 2 Plus. We're only calling it Angular 2 Plus just to make sure that we're not confusing it with the deprecated Angular platform. All right. So, why bother with these at all? Why bother with them at all? Now we're going to pick on Angular only because it's probably the most complex of these. But as I go through this, understand that I am really talking about all of these. Okay, but we're going to pick on Angular as the example. So what are the challenges with Angular and for that matter, some front-end technologies? Well, one, it's the complexity. It's complex. You know, when we're talking about componentization and and reactiveness and things of that nature, it adds a real layer of complexity, right? And there's a steep learning curve compared to, you know, your classic document front end stuff, such as jQuery. jQuery had a really light learning curve, and it was very powerful. And so I move away from that, right? It often requires a new language, so TypeScript or JSX, Dart. Typically, these front-end technologies don't use native ECMAScript or JavaScript languages, right? And so it often requires learning some ECMA superset. Build life cycles can be extremely difficult and unmanageable, and can sometimes build out too large. Sometimes can tree shakeout functionality that you don't want it to. I mean, it takes some know-how to get these to build out in a efficient manner. All right, so it really does take some deep understanding of how babbling and transpiling and things of that nature get handled. Okay. The security models. So when we're talking about front end, you know, a progressive web app or PW model view, whatever technologies, we're really talking about changing how we implement security, right? Oftentimes I'll consult at a place and they're amazed when I tell them, well, we can't block page fetching because we don't page fetch, we only data fetch. And so it throws a real curveball to the classic security models, right? And oftentimes needs a total overhaul or replacement to the security technologies, okay? Another interesting one is oftentimes legacy browsers like IE9, IE10, IE11, any of the IEs, they won't run the new technologies. They just flat out won't run it. They won't have that underlying feature to make that possible. And so we have to add polyfills and shims or transpile to all the way back to ECMA, you know, Common JS or ECMA 5 to get it to work. Okay, so there's some real complex challenges to using these front-end technologies. So why are non-app, non-internet companies picking up these front-end frameworks if they have so many challenges to them? Okay, so that's the question that we want to talk about. And I guess I want to relay that I'm not, this conversation isn't about how these are bad. It's really, why do we use them? Okay. So let's talk about the prioritized reasons to adopt. And these reasons to adopt are right out of almost all of the front-end frameworks documentation. Okay. And then as we walk through these reasons, keep in mind, do most corporations align with these reasons in your experience? Okay, so what I'm going to talk about in my experience is I've been with 15 companies in the last 10 years, consulting at 15 different companies in the last 10 years. And this is my experience on these front-end technologies, and in particular Angular in implementation. All right. Okay, so there's probably a few more, but these are the 4 main prioritized functionalities that that front-end web technologies such as Angular provide. One is progressive web apping. Okay, so progressive web app, we'll get into each one of these, but just at a high level, it acts like a native app. It acts like a phone app, right? It acts like, you know, what's a good phone app? Like TikTok or whatever. Okay, so that's one of the reasons that progressive web app front-end technologies such as Angular were put out. Another reason is it's reactive. So almost all of these technologies either come out of the box or with some simple dependency configuration can become reactive all the way to the database. Okay, all the way to the database. Offline capability. Oftentimes that you'll be in a part of the world or be in a part of a situation where you need it to run offline, right? Or partially offline. For example, train transportation in India has very difficult constant connection capability. So things of that nature. And cross-platform hybrids. A very common use for these front-end technologies is to build native mobile apps using some cross-platform additions to them. Okay, so you'd write it like you would basically any other React or Angular implementation, but you would have a cross-platform component to it. And that saves us from, you know, having 3 different development teams, maybe even 4 different development teams just to put out one app. Okay, so let's dive into these a little bit. So progressive web apps. What is a PWA? Well, a progressive web app is just a unit that is recognized by W3C that acts as basically a full-fledged native application on a mobile device. Okay, and it can be on a desktop too. And I'm sure some of you have seen hints of this with like asking for notifications at websites and, you know, asking to be allowed to send notifications from websites, or asking to be able to put the icon on to your mobile, you know, your mobile wallet or your mobile desktop or your things of that nature. So some of the characteristics of that is a PWA is loaded entirely on the client, entirely. So the application itself is entirely loaded on the client. Angular allows for this. React allows for this with some dependency additions. Vue.js allows for this with some dependency additions. Electron, all of them allow for this to be entirely loaded on the client device, whatever that device is. Like I was saying earlier, progressive web apps can receive notifications just like your regular, you know, native application. If you include a manifest file, PWAs can be loaded from a mobile device's home screen, right? And so you might have been to some PWA websites that ask you, hey, you want us to put an icon on your home screen? And if you say, yeah, you can launch that mobility right from your home screen. And in addition, progressive web apps are compatible with every modern browser, every modern mobile device, including Apple, and every major desktop operating system. Okay, so progressive web apps is a highly adopted implementation, though it might not be highly used implementation. Okay. So here's an example of progressive web app. So with that, that's the work with intention site, which used to be a progressive web app. It's not any longer. It's a marketing site now, but it used to be a progressive web app. And we could add, we did add a manifest to it. And as you can see, we can click, that's a screenshot of my home screen, and we can click on that and it'll open it up. Doesn't look like a browser, right? I mean, it is a web view, but it doesn't look like a browser. And we can move through the, you know, the technologies as we see fit, right? All right, so what are some other considerations for progressive web app? Well, Google has announced that in Q2 in 2021, it's going to move away from the Java-based Android implementation and move to an implementation called Fuchsia. What is Fuchsia? Well, nobody really knows exactly what it is except for the people at Google, but through a lot of media leaks and stuff like that, most of it says it's based around Golang, Node.js, the V8 engine, of course, and it's highly progressive web app compatible, right? So Android and Google in particular are making a push for progressive web apps to take over all device implementations. All right. So Microsoft announced that their next Windows-based implementation will be a Linux-based implementation. Windows will be a Linux kernel. I mean, that's a pretty significant shift in technology for Microsoft, in direction, right, in paradigm. Their latest Edge browser is now Chromium. So if you have the cutting edge, latest Edge browser, you are running Chrome, right? Another major paradigm shift for Microsoft. So why is this? Why is there a major shift? Because, well, in this case with Microsoft, let's face it, Microsoft lost the device game, right? They lost the mobile game. They had mobile phones out for a few years, but it never got any traction, and they lost a handle on that. Now, now you can say that their Office products are downtrending. Now, it's arguable that they're still alive and happy, but they're definitely downtrending. And things like Google Docs and things of that nature are uptrending. And so they see where the patterns are going. So how do you save yourself when you're in that? Well, one, you come out with a good cloud platform, which they did, which is Azure. And two, to make your software landscape alive with no mobile device and losing traction on desktop operating system, what do? Well, you align with the guys that are doing mobile devices. And right now they're aligning with Google on the progressive web app push, right? On the browser push, maybe is the best way to say it. So in the past 2-3 years, there's been real moving over hurdles for progressive web apps to interact with the device's native hardware. So camera, sound, contacts list for some of the software interaction, things of that nature. And it's pretty wide open right now. Now, of course, the last adopters for that is Apple, because Apple would rather not go the progressive web app out because they make a lot of money on their market, right? But both Apple and Android use the same render engine to render their native apps with their web views, right? So the Safari render engine and the Chrome render engine, I'm oversimplifying here a bit, but you get where I'm going with this. The Safari render engine and the Chrome render engine are both ran with the basic render engine for the phone. So there should be no reason that one app, native app, shouldn't be able to look like a progressive web app and vice versa, right? They're using the same Polygon render engine, right? So the only point to this is that there is a push for progressive web apps, and Angular and web front-end web technologies are one of the things to leverage to make those progressive web apps. All right, that's the point. So the other thing is the offline capability. So what's the deal with offline capability? Well, everybody understands where I'm coming from with that. The app can run without being connected to the internet or having partial connection to the internet, right? Or any network for that matter. That leads to some complexity. One is state needs to be managed on the client. That sounds simple, but when you have multiple screens and multiple components on multiple screens, it can get very tricky. And so there are a lot of tools and things of that nature to manage the front end state, okay? But there's a lot of complexity to that. Security needs to be considered. So now when you're dealing with partial offline, you may have API security, but now you have to, because so much of the state is managed for on the client, it becomes untrustworthy. The data becomes untrustworthy because it can be manipulated. It can be. I mean, it's difficult, but a person that builds these kind of technologies for a living could make that happen. And so when you're doing coarse grain updating when you're offline, you need to make the developers need to make sure that that messages that are coming back and forth when they do come back online are clean and allowed and authenticated and authorized. Okay. And like I was saying earlier, there's several frameworks and architectures around client-side management. I'm sure everybody's heard of Flux, or maybe the Flux implementation of Redux. That's a very, very popular one. And there's a Redux implementation or Flux implementation for almost every one of the front-end frameworks. All right, but again, it adds quite a bit of complexity, right? So here's just a diagram of a classic web architecture, right? And so everything's done on the server, very little, almost no offline capability is there. In fact, I would say there is no offline capability. There's just none. You may be able to fetch a page if you're lucky, but most of the time you get the I'm offline, you know, Chrome or Safari error page. Okay, so in the client-side state architecture, you can see that almost all of the information and state, assets, state, down bindings, routings, the service worker, checking for socket subscriptions, all of that is done in the client. Very little, relatively speaking, is done in the web server, at least in this relationship. There's lots of stuff being done on the web server, but in this relationship, there's very little being done. Almost all the management and all the session is done in the client browser. So again, leads to quite a bit of complexity in the client browser. Okay. Now let's move on to reactivity. We had a speaker earlier today talk about reactiveness in Java. He did a fantastic job, and I hope the people here went to that one because it'll ease some of my explanation. But basically, reactivity is getting data, synchronizing data across your platforms, right? Constantly, right? So all the way back to the database. So we're talking about anything that gets updated to the database should react and send data messages to all the other layers. And what, your microservice mesh should send messages down to your UI. And so, for example, if I'm on 2 devices, I should be able to update on one and instantly, without any refreshing, see it on the other, right? So a good example, we'll get down to some good examples at the end, but so how does that work? Well, as the gentleman was speaking earlier, described very well and in detail, it's done through the object observer pattern, right? And so for the front end stuff, for the front end technologies, we usually implement an HTML5 socket or a web socket, and we run subscriptions in a proxy server that keeps live connections attached, so we can send data pushes. I'll use that term loosely. Data pushes down to the client and receive any data pushes up from the client, right? And so it's just your classic object observer pattern, but it's across technologies and across network domains. Okay. So the Flux. From a front end technology side, one of the things that we do to help state management and reactiveness is we introduce a Flux architecture, right? So you can spend a long time on Flux architecture, but the point to it is it aids in the object observer pattern and can be very complex, okay? One of the things to consider when you're doing the object observer pattern is not only do you have to manage state, but the status of that state. So if I have a piece of data that's pending being updated, I need to keep track of that. If I have a piece of data that errored, in receiving or in pushing, I need to keep track of that. Or if it's successful, I need to keep track of that. Especially if I'm using loading states from a UI perspective. So not just the state needs to be kept track of, but the progression of state, right? Oftentimes in a progressive web app too, what we'll do is, in a reactive one, is we'll will do undos, so to speak. You see that all over web and mobile technologies. Like if you have an Android and you swipe right on a song on your playlist, it will say, oh, did you you want to undo that deletion? Well, yeah. How is that managed? And from a state perspective, well, we keep track of the growing state, right? We can keep snapshots of the growing state depending on the status of it. Okay. There are many examples of reactive apps. Google Docs. Everybody's seen Google Docs, right? You type in you type something, and a friend of yours types a comment on it. You can see them actually typing it. Slack, of course, Slack is. We can see it being reactive as we type. I would say most of the major social medias implementations are reactive. DraftKings, just as a side, kind of an aside example, that's a reactive. With player and team stats as they're unfolding real time, and rich communication RCX testing or rich communication service texting, that's reactive as well. If you're on an Android or an RCS compatible device, even we can even use iText or whatever it is as an example. They're reactive, right? They react to your communication with the group or person that you're interacting with. Okay. The point to all this though is this kind of reactiveness object observer pattern is very complex, and it needs to be, to have it work, it needs to be implemented at every level of your landscape. Okay, so here's just a roughed up example of the complexity. So you could see that there's an application server that deals with push notifications, web APIs, sockets subscriptions in this case, the JWT user info for security, browser and local storage, index DB probably in some cases. And to do that, most reactive implementations and state managements use something called the unidirectional data pattern. And we can see a really good example of that, at least in this diagram, right? And so I'm not going to dive deep into the flux pattern, but the point to it is it's just a different pattern than we're used to in a classic web sense, or even just a document browser web sense. And so there is many additional layers of complexity around that. Okay. So here's an example. Now it's an over an exaggeration and an oversimplified example, but here's an example. So here's a promise call, right? To a web service, and I'm just getting a promise, and then I'm getting the data back. Asynchronous call, very simple. Most classic web developers or web developers of any kind have done this kind of call a million times. Now I did leave out the rejected, the error state, but you get the point. The point is that this is a classic data call. This will work. I can put data on the screen by doing this. Now here's the same thing in a flux pattern. Now this is using something called NGRX in Angular, and that's a popular Angular flux pattern. But it's much more complicated, much harder to read, can be much harder to test. It's actually easy to test, but harder to test meaning that you have to test more. But it is much more powerful. If you're doing state management and reactive design, it's much more powerful. Okay, that's the point. If I need those prioritized functionality, this is a really powerful tool to do that. But as you can see between the two, it is exponentially more complicated. All right. Now let's move on to the other prioritized functionality, which is cross-platform hybrids. Right? Everybody's pretty familiar with these by now, at least in theory. We have React Native and Electron, Native Script, and in blue there we have Ionic and Angular. Those are common relationships. Native Script will run actually all of them, but those are common relationships between the front-end technologies and their cross-platform counterpart. They work very well. They work extremely well, actually, for what they do. They will run your app across all mobile devices, all web browsers, and all operating systems. There's some caveats to them, as most people that's implemented them know that there's some caveats to them. Particularly with Apple, you have to do some tricks now and again. So there's probably a little bit of additional code if it's an Apple device and things of that nature. But the point is, in most cases, it sure beats out having to code things up with 3 development teams or more, 4 to 5 development teams just to get it out on individual devices, even though it's exactly the same functionality, right? And so everybody should be relatively familiar with the hybrid frameworks. The point is, this is one of the reasons to have one. This is a prioritized functionality to having a front-end technology, right? And so some widely used implementations for hybrids is, Slack and Facebook, of course, with React Native, and Instagram, Skype, WhatsApp, believe it or not. Here's a big one that I don't think a lot of people realize, YouTube. YouTube is a cross-platform implementation, right? MarketWatch, of course, Airbnb, Strudel. So all of these are cross-platform, right? Or at least have some kind of component of cross-platform implementation. So these are big guys in the industry. So it's a reality that cross-platform does work. It does work. As progressive web apps and things of that roll out, this will get tighter and tighter, okay? So here's the question after we went through all of that. And I think the point of going through all of that is to just have an explanation of like how complex some of these front-end technologies can be. And as we add features, they get more and more complex, right? So I can have a PWA, but not be reactive, things of that nature. And so as we add reactiveness, or as we add offline capability, or as we add hybrid cross-platform, it just keeps adding to the complexity. So does Angular feature priorities line up with many corporations' priorities? Well, what's the answer? No. Most of the time. Most of the time, they don't add up. Like 80% of the time. And this is from my perspective, but it's also from discussions with other developers in this arena. 80% of the time, 80% of the companies that I've been to, they really don't need any of that functionality. And maybe don't need is the wrong statement. They don't want it. That's not part of any of their requirements. Now, a place like a well-known health provider, which the keynote speaker may or may not be part of, well, that's a different story. I mean, we have implemented stuff there that did need this. And so it's not across the board, but oftentimes it's just not needed, right? So what happens there? What are their priorities? What are most non-internet companies' priorities? One big one, almost everywhere I go, is quick development of feature functionality, right? They want to get as much feature functionality out as fast as possible. That's another word for that is speed to market. So we call it speed to market all the time. And so how does that line up with some of these technologies? Well, it really doesn't. It really doesn't. The front-end technologies, particularly Angular, aren't designed to speed up functionality delivery. That's not their point, right? And so if this is a corporation's number one priority, I'm not sure that fits, right? I'm not sure that fits in there. And it's interesting because a lot of corporations will decide to do it before they prioritize their approach. What's another big one that I especially from a lot of CIOs and CTOs, I hear all the time is cross-pollination, technology cross-pollination. That becomes really difficult with front-end technologies because one main reason is because development groups seem to gear themselves to one or other implementation, like React versus Angular versus Vue.js. And I can tell you, I've coded in all of them, deeply, and I could underneath the rug, they're all the same. They're really all the same. They all accomplish kind of the same thing in a slightly different way, but they're really all the same. Okay, but the point is that it's very difficult to cross-pollinate when you have such a steep learning curve, or you have so many frameworks that are syntactically different. It becomes harder to do. Not saying it's impossible, but it's harder to do. So if this is a top priority, of course, it makes more sense to be more browser native, right? Search engine optimization. One of the things that always cracks me up, and I've done it myself, so I have to laugh at myself too, but it is server-side rendering of these client-side components. Clearly, if you're server-side rendering, you are, and all of these frameworks are quite capable of server-side rendering with some server-side help, like Nux.js or Next.js or I forgot Reacts, but they all have a server-side render component. An early one was called Rendertron, and they're all cool, and they all do their purpose, and they actually do it very well. But the whole point of the client-side development, or the client-side execution, is to accomplish those other priorities. Clearly, if I'm doing it server-side, I'm not doing that. I'm totally eliminating all of those prioritized features, all of the reasons to implement it. All right. Now, a big one that I hear all the time from mostly architects is componentization, right? So many architects want standard components, feature-filled components across the enterprise landscape, and so that they can be leveraged by different development groups. Anywhere from like simple buttons to very complicated, search criteria, right? And and there's some argument there if that works or not, but it's a valid question. Componentization is a valid reasoning. Now, is it a prioritized piece of functionality of progressive web apps or of these MVW front-end technologies? That's debatable. I personally would say no, it's not. They do have them, but I don't think that's their point. And here's the reason why I don't think it's their point. Because if a componentization was really a high priority on a front-end framework like React or Angular's roadmap, they would implement things where they could have different technologies and different components, but they don't. If I have React on a site, if I have one React component on a site, I basically am tied to React at that point. Same with Angular. Same with almost all of them, except for a couple of them. Okay. The other kind of other side of componentization is this: that components are native to the browser already. Componentization is already native. I don't need any framework to do that. And I'm amazed that that's not more pervasive. That idea is not more pervasive than it should be. Most front end, at least in the Chicago Midwest area, most front end developers don't know, and never been exposed to, maybe is a better way to say it, that natively I can make components natively, and to some degree better than the frameworks can do. So how is that? Well, in 2014, W3C spec, or W3C, the World Wide Web Compendium, and Google derived the web component specification. Now in 2014, it was just derived. It wasn't implemented really anywhere, but Chrome did lead the pack on that. There are literally no additional technologies needed. Just plain ECMA 6, usually it's ECMA 6+ is all that's required, literally. It has three major parts: HTML templates. So I can import an HTML template just like I would in JavaScript frameworks such as React or Angular or any of those. Custom element, like tags of custom elements, like I'm going to show you one, and it's called, what's it called? Floating navigation button. right? So I can have a tag called floating navigation button. Shadow DOM. Shadow DOM is very interesting because that's how it separates. Shadow DOM is how it separates the components from one from another, so that they can't interact with each other without allowance, right? So I can't see the data or manipulate it or do anything to this component in the shadow DOM or in this root DOM. Now, if you want to see an example of shadow DOM, go to YouTube, because YouTube actually leverages a lot of these technologies, and just do like a view element, and you will see shadow DOMs, right, in the dev tools. Okay. Shadow DOMs is really cool because it allows me to run React, Angular, Vue.js all on their own components on the same website, right next to each other. Totally legit, totally works right out of the box. Need no implementation, native to the browser. And even if you talk to like Jeff, or even if you watch some, talk to or watch some online stuff like Jeff from React and things of that nature, they admit that they should be leveraging that, but they really don't, at least in a pervasive way. They all have small implementations of it, but they really don't do it. And then the HTML module import. I can literally import via HTML components, right? I'll show you an example of that. I should add too, there are also several lightweight frameworks that are available to help with this these native components or boilerplate. And a big one is lit HTML, L-I-T HTML. Okay. And so what's the compatibility of web components? Well, as of 2020, this is the compatibility. It's pretty good, right? It's 100% actually. And so all Even Apple's native browser supports native progressive web apping. I'm exaggerating there, but you get my point. It supports native components, right? So why are we using these heavy frameworks to do that? Just that. That's the real question. So here's an example of one. This is one right out of my own code base. And it's a floating navigation button, like I would make in Angular. There is no framework involved in this. This is all native HTML. So you can see at the top, I am importing an HTML module, right? And you can see that I have the template section, I have the style section, I have the class section with all its data properties. You could see that down towards the nav click that I'm pushing state via native event buses, right? So other components can interact with it. You can see that I'm adding it. You can see that I'm adding this component to the Windows custom element. Yeah, window custom element. That function or that object is native to the browser, right? So I can do Angular React level componentization without importing a single framework. Okay. So what's the point of this? Well, the point is simply this. If speed to market, cross-pollination, and ease of use, all that stuff is a priority, then you might want to consider the level of complexity being introduced by Angular or any other front-end technology, but in particular Angular, because Angular is one of the more complex of them. Is that company, or are you as a development team going to implement those other features? Are you going to implement reactive? Are you going to implement offline? If not, there's some real consideration on that, because it will hinder the other priorities. It just will. And so it's something to think about, right? And so the point is just simply this, that we can just take it a lot easier on ourselves if we just don't adhere to buzzwords and industry standards and things of that nature. And I use that term standards kind of loosely, but like industry fluff. If we don't need that functionality. I want to make it absolutely clear though, I love all those technologies. I love Angular, I love React, I love Vue.js, Electron, I love them all. They're all super powerful to implement progressive web apping, offlining, all that stuff. But if I'm not doing that, they are an anchor. they are making it much more difficult for me to teach somebody. They're making it much more difficult for me to get stuff out in a timely manner. It's making it much more difficult in my browser compatibility. It's making it much more difficult in my build processing. Across the board, it's making it more difficult. And if I'm not gaining the benefit of those front-end technologies, I should probably question, should I bring them in? All right. And that's it. That's the presentation. So I'll wait for any comments or questions. Actually, I can't tell if I have any. So, okay, if there's no comments, I'm going to drop off. I can share this out on I can share this deck out on the Cloud Conference panel later on. So if you wanted to look at it later, feel free to. Oh, one popped in. Oh, you're welcome. Thank you. Bye, everybody.